tired. Dropbox, DIFC, workbook, mechanics, no, physics, mechanics. What's wrong?
Where's Samuel?
He's down at the elevator.
Why?
I don't know. He said he'd be late. He's sitting down by the elevator. You know why?
I don't know.
I don't know. He's doing something anyways. He said he'll be here in a few minutes. Okay, let's continue. Work.
What's called work?
Work, yeah. Yep.
The unit is J. Oh, J.
J.
What's J?
What's J?
This work.
J.
J.
No.
No.
That, but 它像 looks like
Looks like what?
J.
W J what?
Oh, come on. What's wrong, Gav? You know this letter. A, B, C, D, E, F, G, H, I, J.
Yeah, I know it's J, but I didn't understand what he's saying. What's the problem with J?
No.
I just
She'll see later. She'll see. Yes.
Unit.
Yes, correct. Work unit. J.
Work unit? Is
No,
that
you'll see.
unit?
You'll see. You'll see.
Okay,
You'll see.
okay.
So,
What? We passed something.
I know not just what we're going to do today.
Okay.
I know what we're going to do, so don't worry. So in this picture, work is being done. What things are needed for work to be done? So if you look at this picture, what do you need to have some work? Well, energy is one, yep. Also there needs to be a force. So the man is doing some force. The man is applying a force. He's doing work, he's applying a force. What else? The force is making something move. So what is being moved here?
His body?
Well, yeah, his body and the ground as well and all this here. The sand is being moved. And you notice in this picture the force and the movement of the sand are in the same direction. So like, if I want to move this, I have to do work. And I have to take a force in the direction I want to move it. So if I want to move this from here to here, I need a force to move it. Yeah? So, this is what we mean when we say doing work. Do you understand? So, if I want to do work, like throw this at Ben, I need a force and a direction. Yeah. Also, there's usually an area. So, for example, my finger, there's this area, pushing it, you know. Or if I push with my hand, it's this area. Okay, so these are usually the things that you have. So this is the idea. Let's get to the definition. So when we say there's some work done by a force acting on a body in a direction, we say that the work done is the force multiplied by the displacement. So simply as a formula, we say work is force multiplied by displacement. Now this is really important. It's the force in the direction of the displacement. Okay? So the force and the direction need to be the same. That's very important. And this is the definition of work. So, what would be the unit of work if you look at this? Well, what's the unit of F?
In Newton.
Newton. And S? Meters. So work is measured in Newton meters. However, the units are usually called the joule.
Joule.
And we say that 1 joule means 1 Newton for 1 meter. In other words, 1 joule is the same thing as 1 Newton meter. What word are you checking?
Joule. I wonder-
Ah, it's a person's name.
Yeah, but I get something of heating, you know, we call it like kJ.
Kilojoules. It's the same.
Is the same?
Mm.
I only know the joules for heating. I'm not sure about work.
Yeah, but joules and heat and measures the work done to heat something. It's the same. Go check it. Go on, check. You need to write down
Yeah.
both boxes.
Okay.
Okay. Both boxes. Write down everything. I'm sorry, everything. Good. And Ben, you got this box? Good job. So you knew about joules already. You studied this in China? Is it called joules in China? No?
Similar.
Oh, close.
小
Ah, nearly the same. Did you have maths today?
Yeah.
What are you
Just
doing?
finished.
Just
now.
finished maths.
Just finished?
Yeah.
Finished what?
Maths.
Yeah, but what topic?
Quadratic,
line.
is right?
Quadratic?
Yeah.
Do you do cubic?
Yes, I guess, yeah.
X cubed?
Yes, S cubed. Yeah.
Okay. Ready, Summer?
Yeah,
Which part are you at?
the last sentence.
It is the same as 1 Newton meter.
Yeah,
Wonderful. Wonderful.
finished.
Okay, good job, good job. Okay, so in each of these examples, I want us to say where and what is doing the work. So a mother lifting her baby up from the ground. What's the force? It's in her arms. Okay. And what's the direction? It's up. And what is the work being done to? The work is being done to the baby. The baby is having the work done to it. You know, like if I push this, this is the force, this is the direction, and I'm doing work to the remote. Yeah. Right, now you guys tell me. A woman pushing a large box across the ground. So what's the force here?
Arm.
The arm pushing, yeah? And the direction is horizontal,
Closed.
across the ground, yeah? And what's the work being done to? The box, yeah. A man kicking a football,
The work is his leg.
the work
The
is
first
yeah.
is his leg.
in his leg, yeah?
The position is vertical. No.
Horizontal.
Horizontal, sorry.
Yeah.
Then the football is the walk, right?
The
Work done is-
work done to the football.
Yeah.
What's the distance? Yeah, what would it be?
It's going to be the same as the walk. Done.
Like when you kick a football,
Okay.
what distance do you use in the formula? Work is force multiply distance. So you kick the football, off it goes. What's the distance?
So work divided for
80.
Oh yeah, but like, I'll give you an example. I kick a football here to there. What do I use as the distance? Do I use, you know, if the ball goes like this,
the horizontal.
the horizontal distance.
From here to here.
Okay, good. No.
No.
Because the force isn't applied for this whole distance.
In the middle of the highest
Yeah.
point is the legs force give to the ball.
Yeah, and what's the distance?
In the half of the
Half of the height?
yeah no it's a whole line from the beginning to the
Oh, I see. You're saying this distance.
yeah this
This distance.
yeah
Just this half.
just this half no it's this whole the whole line
The whole line,
whole line's half of the whole line's
half of her answer.
yeah.
No, not this.
No?
No. Because the force isn't on the ball for this distance. The answer is, maybe it's only like this distance. It's the distance he moves the ball when his foot is touching the ball. But as soon as the ball leaves his foot, no more work is being done.
Yeah.
So it's actually a small distance. Yeah?
Yeah.
Because work is force multiplied distance. If there's no force, then there's no work.
Yeah.
So as soon as he kicks the ball, that's the distance. But no more work after that. Yeah? Is that okay?
You need to touch.
Yeah. Touch it. The time he's touching it. Yeah. Now, this is a harder one. A child hitting the wall. So the force is in the arm,
Okay.
and the direction is horizontal, and the work is being done to the wall.
Okay.
But what's the distance here?
0.
0.
No, because if it's 0, then that means there's no work.
If
Yeah.
the child hitting the
Yeah.
wall, that must be little yeah.
Small distance.
Yeah, it's
The
small.
distance the hand
Enters.
compresses. Yeah. Small distance. Yeah. And the last one's really hard. A father carrying his child on his shoulders. So what's the force here?
The force is his shoulders.
Yeah, like the support.
Yeah.
Yeah. What's the distance?
It's also
Close.
The leg, entrance of the leg.
Yeah,
Shoulder
it's
leg.
a small distance because as he walks, maybe he's moving up and down a little bit, you know. So that's there's actually many things that are happening, but one example is that as he's walking, he's pushing the child up and down. So he's doing work like this. Okay, so you see, not very, very easy. The last one was actually interesting. So the point is, remember that the force and the direction must be the same, and it's force multiplied by distance. Okay. So sometimes you have to resolve. So I'll explain this with a picture. Like, for example, if you had something like this, and you're pulling here, and the box moves this way, yeah?
Yeah.
The work is Fx times the distance. You have to take this part here. If you resolve it, do you know what I mean?
Yeah.
Like this. Yeah? So, let's have a look at an example. A woman pushes a 100 kilogram box along a smooth ground. The block is at, well, I should say box. The box is at rest, and then it reaches a speed of 1 meter per second in 5 seconds. So it's at rest, and then she starts to push it, and then after 5 seconds, it's going at 1 meter per second. So I think you can do this one, because the first question is, what is the acceleration? How do you calculate that? Acceleration. The UVATS. How can you get the distance? The same. What about part C? How can you get the force? How do you calculate force in part C?
How do we get work?
No, first, how do you get force?
Oh, okay.
How do you calculate F?
F.
Yeah, F equals ma, yeah? F equals ma, right? And then D, how do you calculate the work?
Fs.
Fs, which is the answer for C, multiply the answer for B. Yeah? And then the last part is, instead of pushing at 0 degrees, she now pushes up at 10 degrees. So you get a different answer. I think you can do at least A, B, C, D. Well, you can definitely do A, B, C, because we did that last week.
Yes.
So can you try and do this now, and then I'll do it in a minute once you get an answer. We'll see if we can get it right. You missed those formulas. You need to watch those videos for UVATS.
20 force of 20 Newton.
For C,
Yeah.
did you get work?
15.
15?
0.
Are you sure?
No, sure.
What's the distance?
Distance 2.5.
2.5 multiply
F20.
20. Yeah. 50. Yeah.
Was.
Let's calculate
What
now.
was 15?
The work.
Oh, work. Oh,
He
sorry.
thinks.
I didn't get work.
Yeah. Maybe he's wrong.
Easy.
Well, maybe you're wrong.
No problem. Nobody cares.
Ah, you're right.
And
Do you have class at 9 o'clock today?
No, at 10.
10 o'clock.
Yeah, it's fine.
Got an answer? Oh, let's see then. Let's see. Right, the first one. U, 0. V, don't know.
Don't know.
Oh, sorry.
One.
1. A, don't know. T,
5.
5. S, don't know. Okay. Let's see. Back. V equals U plus A
T.
T. So A is 0.2
Yeah.
meters per second squared. S equals UT plus a half A T squared. So S is 2.5 meters.
Yes.
Force equals MA.
I'm
And-
A. I'm S.
MS, oh, chow. That's 100 times 2.5, yeah? No, times
0.2.
times 0.2. That's 20 newtons.
Yeah.
Work is Fs, which is 20 multiplied 2.5, which is 50 joules. Yeah? So the last part is if instead the force is at an angle of 10 degrees. So the
10 degree.
yeah. Isn't I say 10? Yeah.
Okay.
So the only difference is the F you should use should be F cos 10.
Cos 10, yeah.
So it means now the work is going to be 50 cos 10.
That's cos 10.
Yeah.
Yeah, that's
49.2.
Now, just to be clear, there's 49.2 joules of work done to the box. But the woman probably still did 50 joules of work because she probably wasted energy getting, how can I explain this? Like,
But I remember it's smooth.
yeah, but what I mean is like, if I push here with 50 newtons, or if I push up with 50 newtons, my body gets just as tired. The only thing that's different is less work is done to the block. So maybe she's wasting energy by getting warmer or something. I don't know. Just to be careful with the English, okay? I shouldn't say the woman did 49.2 joules of work. I should say there was 49.2 joules of work done to the box.
Okay.
Like, they're different things. You know? Like, I could do 100 joules of work trying to fight Ben, but if I don't touch Ben,
Miss.
if I miss, then I've done no work to him, even though I've, moved. Yeah? Is okay?
Yeah.
Somewhere you don't look
yeah.
happy. Are you sure?
Yeah.
Okay, I trust you. Right. And there's also something else that's happening here. Tell me, why does standing on one foot feel more difficult? I mean, your weight is the same, isn't it? But why is it more painful to stand on one foot instead of two?
One reason is better.
You know? Yeah, but the weight's the same, so what's different?
So the S is the S.
Not S, no.
What do we call S? Like
No.
square meter.
No, yeah, what do you call that?
S.
No.
We say S is
S
square
is just this.
But R is this. S is square meter.
No.
Yeah, right.
No, don't. Summer doesn't want to be involved in this. Area.
Yeah.
Area.
But what we call is S.
That's distance.
No, like triangle. If we got this by this,
S
Right.
equals.
it's S.
But I
Oh no, no,
What do
no,
we
no.
call it?
Big A.
面积
Big
面
A.
积不是 S 吗？
Area.
英语是
What? No,
Okay,
Okay, so we're different. In
Yeah.
China, we call the area as.
Oh no, that's terrible.
So
Call it
square.
A. Big A.
Big A.
Okay, big.
Big A for area, yeah?
Okay.
Yeah.
no
Okay.
problem.
Okay. Right, anyways, it's because the area is different. What about if you stand on one toe?
Toe, what's
Oh.
toe?
What's toe? This is finger. It's toe.
Okay.
Kung Fu.
Yeah.
Chinese.
No, not kung fu.
How can we stand like one toe, like ballet dance or something?
That's correct. The ballerina can stand on one toe, like here. This is quite painful.
Really painful.
Really painful. Because all your weight is on an area like this big. That's actually quite painful. And the reason for that is we have something called pressure.
Yeah.
Pressure means the force in the area. Okay? So like if I stand on 2 feet, it's the same weight as 1 foot, but the pressure is 2 times bigger. You understand pressure? Okay, let's continue. What's the English word for her job? You said it a minute ago. Ballerina.
Okay, whatever.
Ballerina.
Ballet.
Stuck. Come on.
Ballet.
Ballerina.
Yeah, he said Chinese. That's what we call it in Chinese.
What's it in Chinese?
Ballet.
Really? For the person?
No, for this kind of dance.
Yeah, the dance is called ballet,
Oh.
but the person is called ballerina. What's it called in China?
That's different. That's different.
Totally different.
The job, if like we call this person, is totally different.
Yeah, what
we
is
only
it?
have to ballet, 舞者. This kind of
Ah.
stuff is very different.
Ballet lucha. Yeah, okay. Yeah, ballerina. Ah, it's stuck.
Oh, terrible.
Old laptop. Come on. Oh, there we go. Got it. Okay. So, pressure means how much something is pushing on something else. As a formula, it's simply force divided by area. That's all. I think you knew this already. P is pressure, F is force, and A is area. Wait, before you write it down, what's the unit if you look at this? What's the unit for pressure?
So,
Newton.
Newton?
minus, no,
Mine? No.
meter, no,
Yeah,
square meter.
Newton per meter squared. Yeah? The units we use are Pascal,
Pascal.
but you know Pascal? But 1 Pascal just means 1 Newton right angles to 1 meter squared. In other words, 1 Pascal is just 1 Newton per meter squared. It's the same thing. Yeah? Okay, again, whole thing please. So in China, no, not Chinese, not Chinese. Do you write P equals F over S?
Yeah. Yes,
Really?
Yes, S.
Oh, interesting.
We
Like,
call area is S, and
Okay.
we call S is lungs, so we write
Ow.
down air.
Okay. Interesting. Is Pascal in Chinese?
Pascal.
Yeah, totally the same. You've seen Pascal before? Or is this a new word for you?
No, it's not.
Say again?
It's not a new word.
You've seen it before, Pascal. Yeah.
But I can't remember what it means.
Okay. Got that?
Mm.
Yeah, continue. Yeah. So, let's have a look at an example. We're back to the same example with the woman pushing the box. It's 100 kilograms, starts at rest, 1 meter per second, 5 seconds. Do you remember what the force was? I think we worked it out as 20 newtons?
Yeah.
Okay. Here's my question for you. Her hands are each 100 centimeters squared in area. How much pressure is in her hands? So she's pushing the block. What's the pressure? Okay, so you can say that the force is 20 newtons. Okay, calculate the pressure. Yeah, you might need a calculator.
I need a calculator.
Wow, no, you don't need it.
Is that 10?
10 pascals? Maybe. I'll have to calculate.
Is 10. Is 20.
Interesting.
2.
2, 10 and 20. Great.
So two hands.
Oh, which her hands are each.
Oh, each.
So
Yeah. Yeah, it's
See, Summer? 1,
yeah,
2.
Yeah.
Yeah,
Oh,
okay.
2.
Yeah, 2 hands. Yes, correct.
Oh
10.
my god. 1.
One
10.
half?
Let's calculate.
Yeah.
How did you get 10 then?
Well, I'll give you the true answer. So, what's the formula for pressure? Force over area. What's the force? 20. And the area is 2 times. Now we have to figure this out. So it's 100 centimeters squared,
Yeah.
which equals 100 centi squared meter squared.
Yeah.
Remember doing this?
Oh. Oh, wrong.
Wrong square.
Whoops,
Too much.
too many zeros.
Too many.
Yeah? What's wrong?
Oh. I forgot. I think the.
But I always wrong.
Yeah.
So that's 0.1.
Yeah.
So anyways, that goes in there 10 times. So the answer, you were all wrong. Congratulations. 100
Yeah.
pascals is the answer.
No, it's
No. Ah, why are you multiplying? I'm confused.
yeah. 100 multiplied
100 multiplied this is not 0.1?
0.01. Am I wrong?
Oh no, I think I'm wrong. What did I do wrong? How many here? 4, isn't it? 1, 2, 3. No, you're right. Forget it. Sorry. Be quiet, Stephen. 0.01. I'm wrong. 0.01. Ah, so the answer is 1,000.
Nobody got it right.
Nobody got it right. 1 kilo Pascal is the answer.
100.
You missed this lesson. It was the first lesson. Did you watch this video?
But 100 cm square means
Yeah. Yeah. It does.
yeah, and right?
Yes.
Yes.
Yes. That's what we have here.
Yeah. Yeah. That's right.
Oh, I know it's right. Okay, you got that?
Yeah, I got
Yeah. Okay, let's see. How long will we do this for? Just for about 5 or 10 minutes. The next lesson is very easy.
You only one class?
2 classes.
Oh.
But the next lesson is super easy.
Oh,
Super easy. Super easy. Lots of pictures.
Can we finish faster?
No, because I want you to try some of these. Yeah?
Yeah.
Because nobody got this right. So I think
because of the
Ah, yeah, okay.
0.01.
Yeah. Okay. Let us try some questions on this page. Only for like 5 or 10 minutes. It won't kill you. You're strong enough. You'll manage.
What?
Because you'll have to finish this for Monday.
1,
Yeah.
2, 3, 4, 5, 6.
Yeah.
Well, which?
Start now and finish for Monday.
Yeah.
Finish for Monday.
Yeah.
A father. Leave meaning just.
Yep.